On YouTube. I just hit look, I'm recording. So every class except for first block has been recorded. Every class does a different set of questions. There's not many questions left, and I'm back at the beginning of this packet. So when I'm done with this, I'm going to do the beginning of the packet again. Okay. So that eventually the entire packet is on YouTube.
Can we just type in like Mr. Como and it'll bring us
That's
to
it.
the account?
Yes.
I took your dad the other day.
No one cares. All right. In question 8, circle O. In circle O, which term correctly identifies x, y? Find x, y. Here's x. Here's y. What kind of line is that? Is it a chord?
Yes.
Is it a radius?
No.
Is it a secant?
No.
A tangent?
No.
What's your answer?
Chord. Oh.
A chord starts and stops on the circle. A secant goes through the circle and intersects it twice. X, Y goes through the circle and intersects it twice. OA, there's your radius. These two are chords. And this line is a tangent. This is definitely a day 1 type question. Day 1 you are going to be, it's going to be so easy it's ridiculous. Jeremiah, day 1, it was like stupid easy.
Was this on there easy?
Do not, because I'm not allowed to know anything. Alright, 9. To win a carnival game, you must throw a dart and hit 1 of the 25 circles on the dartboard. That is 4 by 3. The diameter of each circle is 4 inches. This is going to be a geometric probability. Approximately, which means you have to round. What is the probability that a random dart thrown hits the board and a circle? So what's the probability that you win? So first of all, you have to find the area of the entire dartboard, which is 4 times 3, or 12. So the B stands for board. The board is 12 square feet. They told you that the diameter of each circle is 4 inches. So what's the radius? 2. So each circle, the area is pi r squared. Your radius is 2, so it's 2 squared pi, or each circle is 4 pi. Did they tell you how many circles were on there? 25 circles. So we're going to multiply 4 pi times 25, because if this is the area of one circle, I need the area of all 25 circles. Multiply it by 25, and you have 100 pi. So this is the area of all the circles. Problem, this is in inches and my board was in feet. Which is easier to convert, 100 pi to feet or 12 feet to inches? That's 12 square feet though.
No.
So that's an area. So how many inches are in a foot?
No.
There's 12 inches in a foot, but I'm in area, so I need to be here. So 12 times 12 is 144. So we're going to multiply this by 144. So open the door. So this is 1,728 inches. To find the probability that we are going to hit one of the circles, you're going to take 100 pi and divide it by 1,728. I converted my 12 square feet into squared inches. So if you take 100 times pi and divide it by 1,728, you have an 18% chance.
Is this another geometric property?
Yep. That you are going to hit the balloon. Which sounds about right for a carnival game because they make it look good, but the odds are definitely in their favor every time.
I guess correctly.
Alright, find the area of the figure. I hate this. For this shape,
That's too easy, man. Oh no, they gotta find the perpendicular height.
cut it into two shapes. The area of the square is definitely easy, 32 times 26, which is,
I didn't hear a word you said.
then you should listen. You're trying to find the area of the whole shape, so in order to do that, break it into two shapes, a square and a triangle, or a rectangle and a triangle. The area of the rectangle is 32 times 26, which is 832. The area of the triangle, you need base times perpendicular height.
Wait, do we get the sheet that tells you what to do?
You get the reference sheet, but on this reference sheet there are no, zero, none area formulas. And when I mean none, I mean there's none.
There's none, that's it.
You have trig, volume, slope, intercept, point, slope, and on the other side you have conversions. But you do have a lot of white space. So if you do remember anything, before you start the test, both sides, a lot of white space. The last thing you should be studying on Monday morning, Sunday night, is all the formulas that you will need that are not on this reference sheet. Don't do any math, formulas only. Your transformation rules only. That way when you get in here, your special right triangles, as soon as you get this and a pencil, you're writing all that down in all of this white space before you start the test.
Is this on the computer or?
Yes. It's all on the computer.
Wait, the reference sheet is on the computer?
No, the reference sheet you will get a physical copy.
Right on the computer screen?
Some students try.
Please don't do that.
We see it, but
We-
don't do that.
That's why we have to make a seating chart so they can go in after school and see who damaged the computer and go back to the seating chart and say, Kayla,
Kayla, I would never.
I know you would never.
Don't pop off the keys and spell Mustang in the home row that some of our students have done in the past.
All right. The area of a triangle. The area of a triangle is base times perpendicular height divided by 2. This triangle, the base, is 32. The perpendicular height, because I didn't give it to you, the perpendicular height, since this is isosceles, they did that on purpose, the perpendicular height bisects the base. So instead of 32, what's half of 32? 16, so each side is 16. I'm only dealing with this right triangle because I need to find the perpendicular height. How do you find the missing side of a right triangle? Which is called Pythagorean Theorem. 20, is it labeling a side or your hypotenuse? The hypotenuse. So you have a squared plus 16 squared equals 20 squared. Is this another 3, 4, 5?
Yeah, I was surprised you didn't say that first. But do it the long way and then
All right.
do the short way.
So a squared plus, what is 16 squared?
256.
Equals 400 squared, or 400. Subtract 256, a squared equals,
Slide up.
144.
144. The square root of 144 is? That is your perpendicular height. So the base of the triangle is 32. The perpendicular height we just found out was 12. Multiply them together and divide by 2. The area of the triangle is 192. That still doesn't give me the right answer because the area of the triangle is 192. The area of the square is 832. You have to add those two together to get the area of the entire shape. There's your answer.
Are you going to show them with the 3, 4, 5?
Yes. All right. This triangle, I'm going to take it out and put it right here. Those were the two sides of my triangle. I'm looking for this side. Remember how I said most of the stuff you see in life are all right triangles because it's the easiest triangle to make a problem after? That's a special right triangle. That's your 3, 4, 5. You know your hypotenuse is always supposed to be 5. So 20 divided by 5 is what? 4. That tells you that you multiplied this times 4. So 16 divided by 4 is 4. So if this is supposed to be my 3, it's not 3. It's 3 times 4, or it's a 3, 4, 5 triangle multiplied by a scale factor of 4. Each side was multiplied by 4.
Now, do you think that too many steps for one problem? That's what I was thinking about.
No. Not for the EOC.
Yeah, me too. I agree.
Because it's not hard. The difficulty's not there.
I mean, they're just asking them for the area of the whole shape. But you have to know the Pythagorean Theorem. You have to know the formula for area of square.
You have to know that the isosceles triangle bisects the base.
Yeah, I mean,
Maybe they'll give them the height
if
right
they gave them the
here.
perpendicular height, I could see that being on the test. But anyway, it's still good review, and you do have to know that and how to apply it.
It's a great question.
It's a great
I
question.
think it is too much work.
It's a level 1 easy question.
Yeah, me too.
If you guys haven't learned that you can't believe like 96% of what Mr. Como says, then you've not been in his class.
But that 4%, watch out, because it'll bite you in the
4%,
ass.
That was, yeah, life-changing stuff.
Should have had
Brain board,
Did you lie about that? Wait, Michelle. Did you lie about that? Yes, you lied about that. Remember my extra credit I was going to get? She said you were like 2 hours.
Do you remember that?
Are you still recording? I'll remember that. Wait, did you say that? No, he gave it to you. It was like
0.001 points on a test or something. Yeah.
Wow.
Yeah.
Wow.
All right, week 8.
You have to put my extra credit back.
She wants it back. She wants to apply it somewhere else.
0.0001.
Jenna, or Kayla, sorry Jenna, I'm sorry. Sorry. I am sorry. Jenna, I am sorry.
Yeah, I don't know where you got that.
It's a joke. It's a joke, guys. It's a joke.
All right, what is the approximate area of the trapezoid? This one looks like fun. The area of the trapezoid that we can't use for this problem is base 1 plus base 2 times the height divided by 2. They didn't give me the base. What am I going to have to do? I'm going to have to take this and create a triangle. If this is 8, that's 8. That is definitely a 30, 60, 90. The hypotenuse, should I draw it out?
Did you tell them what you're looking for? No. You just started to do stuff.
Yeah.
Why are you even here?
I like her better.
How many classes have said that?
After question 1 on this page, I will forfeit my pen over to the better math teacher.
Keep going.
I'm ready.
You have to find, actually you got to find two things. You got to find the perpendicular height and base 2. I know this is 12 because I just created a rectangle. Whatever this triangle is going to be, this one's going to match it because they're going to be congruent. So using the 30, 60, 90, I have to find both sides. The hypotenuse is 8. This is my hypotenuse. So if my hypotenuse was 8, what is my x? 4. So across from the 30 is 4. That means this piece is 4. So is that one. So now I know the entire base, which is 12 plus 8, or 20. I have to find the perpendicular height, which is going to be 4 root 3. The height is 4 root 3. So the area of a trapezoid, base 1 plus base 2 times your height divided by 2. Base 1 is 12. Base 2 is 20. Your height is 4 root 3 divided by 2.
Now this would be on the calculator portion, definitely, because of your
Radical.
square root there.
20 plus 12 times 4 root 3 divided by 2. 32 times 4.
Plug it into the calculator.
$32 times 4 times 3 radical divided by 2. Your answer is?
110.8.
What's that?
You don't have to do the square root of 3 first?
You don't have to because I did times 3 radical.
Well, you know, find the calculator out of the way for me.
She's going to do it differently but get the same answer.
I'm just verifying. Is it?
You
Yeah, it's the same. It's the same. See, verification is key. It's the same. So she can kill our young people.
What's in the back of the room?
It's right there.
That's not mine.
So you're on Summers.
No.
Now this, slide it up. Well, I mean, I can say the thing, doesn't matter. So this is like, in my opinion, like a perfect example of an EOC level type question. I mean, but look at all the things. This is what they will do to you. They say, oh, you're just finding area of a trapezoid, but to get there, you have to, number one, recognize that you're missing 2 pieces of information. Then you have to know, oh wait, I got to use what I learned about special right triangles here. You've got to know your 30, 60, 90.
Or
to
trig.
find the, or trig, yeah, to find the base. Well, yeah, you could do trig on that, couldn't you? But I think this is easier.
I do too.
You get nicer numbers to work with. And then you have to remember your
Area of a trapezoid.
area of a trapezoid formula, which again is not provided on your reference sheet. What I would do is just make like, I mean, how many area formulas are there? There's only like, what, 5 or 6? The same ones you've been seeing for years.
Base times height divided by 2, diagonal 1 times diagonal 2, and a circle.
May, can you make half of those flashcards and just, flip through them, and then you can just write them down. Down behind your reference sheet. Review those, dump it down on there. Exactly, do it. Anything you can write down on your reference sheet, you get to use. Wait, can you tell us which ones are for? Yeah, I'm talking about being more specific, like circle, square, trapezoid, rectangle.
This is for squares, rectangles, parallelograms.
Draw the little pictures next to them. Oh, yes. Is it so? Please.
Thank you.
Beautiful.
Yeah.
Triangles.
That's not at all of it. You should stick to math.
She's snatching your way. Drawing is a part of math.
Who said that?
Is that a kite and a rhombus you're drawing? Maybe you could put congruent markers on there so that they know what you're doing.
Write out the name.
Beautiful.
Diagonal 1 and diagonal 2.
What should we learn?
Huh?
Can we take a picture of that?
Rhombus and a kite.
Yeah,
Take a picture.
I'm gonna just write this.
Nice.
You're in the way.
I got it.
All right. Oh, I'm sorry. Were you guys still looking at that? I'm sorry. I'm sorry. Oh, come on now, guys. Say that again. For the rhombus and the kite, the area, if they ask you, I don't think you'll get a question about that, but I mean, because it's kind of just, it's not a question I see a lot of, but if they do give you a question for the area of a rhombus or a kite, it's the two diagonals, it's the product of the two diagonals, so diagonal 1 times diagonal 2, and then you cut it in half. Most likely it's going to be like a trapezoid or like the little house that you break it up. It'll be something, it'll be something like, I've seen different problems like these, where maybe it'll be a rectangle and then it'll have like half a circle. So it's pretty basic, but you have to recognize that this is a rectangle, you have to recognize that that is half a circle, and then find the areas of each and then just add them up. So those are the type of questions that you're more likely to get versus a kite or a rhombus, but those are the formulas if you need them. All right, so are we ready for number 2? All right. This is another good one right here. All right, so step 1 is to read, step 2 is to draw, which they provided a picture. So if we read this, what are they telling us? It's a logo for a company. Does that tell us anything about the problem? No. It's just a nice little story. Good for them. It's a logo. All right. If the diameter of the circle is 8 centimeters, what is the approximate area of the shaded part of the logo? So what I want you guys to think about here, all right, we've got some shapes in here. All right, what's one of the shapes that we have?
Triangle.
All right, there's a triangle. How many triangles are there?
2.
There are 2. What type of triangles are they?
Equilateral.
Right.
Oh no.
I only see congruent marks on the side, which, by the way, are not really well visible on the camera. So there are little congruent marks on these.
Oh, it's right triangle.
Right? So can we say that that's a right triangle?
Yeah.
No. I mean, it's not marked 90 degrees. But, ooh, this is a good one. What do they tell us about the diameter?
It's 8 centimeters.
It's 8 centimeters, right? So look at this. This is the diameter of the circle. Right? That's 8 centimeters. Now, we can use the facts, and again, I'm just basically like looking at what they've given us to work with, okay? Because I want to figure out that this is a right angle, and it actually is. It actually is, but the way to prove that, this is the diameter of the circle. So this is exactly half of the circle. How many degrees is that? 160 is close, but no. 180, right? Now, if this is 180, how do I know that this is in fact a 90 degree angle?
Because
half of 180 is 90, and how do I know that the measure of this angle is half of this one?
Because it's a congruent line.
It's an inscribed angle. So if it's an inscribed angle, then the measure of that is equal to half. So these are. Now again, I haven't even looked at the bottom to see what they're asking for. I'm just trying to label all the information I know, and it's good review for other questions you might have. So this is 90 because this is an inscribed angle. Those are isosceles triangles. They are also right triangles, right? Would those be special right triangles? You have a right triangle and you know the legs are congruent. What type of triangle is that? It is special. What are the special right triangles?
9.
Isn't it like 3, 4, 5?
9 and 12.
Yeah, you could say that one. Well, what are the other ones?
9 and 12.
Right? Those are the Pythagorean triples. That tells us something about the lengths of the sides, right? But if we're talking about the angles, think about the angles. What type of triangle? Special right triangle.
30.
30, 60, 90. What would this one be if the two sides are congruent? This one is not, 30, 60, 90 is a special right triangle, but it's
Area
not
over there kind of looks like 5.
30, 60, 90 is one of the special right triangles. What's the other one? If the legs are congruent.
Have 45?
Might be 45 in there.
45, 45.
Oh, the 45.
There you go. 45, 45, 90. Again, I don't know what I'm going to need to solve this problem. I just wanted to jog your memories on all that information. So based off of what they gave us, we know all of that about the shape. And also, what type of shape is inside that circle?
Square.
There is a square, right?
Yeah.
So they tell us that this is a circle. They do not tell you, let me just emphasize this. They do not tell you that the shape inside there is a square, all right? But we can prove it's a square because they gave us that all four sides are congruent. They told us that. And using our inscribed angle, is that a theorem or a postulate, Mr. Como?
Inscribed angle postulate.
Inscribed angle postulate, you know this is a 90-degree angle. So that's the definition of a square. 4 congruent sides and at least one 90-degree angle because they all have to be the same. All right, so we know all this stuff now. What do they actually want to know about the problem?
The area of the shaded part.
Okay, so let's talk about our plan of attack. If I want to know the area of the shaded region, right, there's two main shapes up there. The square and the circle and the triangle, right? So we need to find the area of what figures? We need to find the area of the circle. We need to find the area of the square and then do what with it? We're going to subtract, right? And so what's left over is the answer to our problem. Now notice that they did not give us the area, or they did not give us the length of the side. They only gave us the diameter. So it looks like we're going to have to use our special right triangle trick on here. All right? Are you like teaching on the side?
No.
So
She's right here.
I've just been like going over all the information that's there. All right. Now to set up to actually solve the special right triangle, right? One of the triangles. I know that the length of the hypotenuse is what? They gave it to me.
8 centimeters.
Right here. This is the hypotenuse. That's 8 centimeters. Okay. And what do we know about our 45, 45, 90? I got to make sure you guys can see this. So the 45-degree angle goes to, isn't that how you wrote it?
The 90 goes on the square.
So this is length x, and this is x root 2, right?
Yes.
Okay. So 8 is equal to x root 2, correct? This is where you say yes.
Yes.
Yes. All right, so how can we figure out what x is? I can solve for x, yeah. How can I solve for x?
I taught them a shortcut on this because I showed them rationalizing the denominator, which they should have learned by now, correct?
I'm going to say yeah, but nobody ever knows it.
But it's not algebra 2.
So am I not doing this?
Standard,
I'm not doing this the way that you would be doing it?
No, right, well,
I don't know what that is.
Yes.
I mean, they're gonna have to plug it into a calculator anyway, so.
I always told them, you take the number inside the radical and divide by it, and then stick the radical behind it. So it would be 8 divided by 2, which is 4, and then stick the root 2 behind it, so it's 4 root 2.
Okay.
Khan Academy, Math Nation. Do you know what I'm saying now? If you rationalize the denominator, you're going to get...
Yes, I know what you're saying, but I'm trying...
Rationalize the denominator of these kids.
They don't know what that means. Okay. All right. Well, we're on the right track, so let's keep going because we need to find so we need to find the length of the side of the square to find the area of the square. Okay. So how can we solve for x here? We know that 8 is equal to x root 2.
I get x by itself. Why is that so hard? It's not. Man, my fingers are solid.
Okay.
We're going to rationalize.
All right. Now this says approximate. So at this point, we could plug this into the calculator and round, and we would be able to pick out the answer choices here. But on your end of course exam, you shouldn't round until the very last step. All right. So what do you think I should do? Just plug it in here and round, just for the sake of getting through the problem?
No.
Mr. Como, I'm looking to you.
Plug it in around.
Plug it in around it? Okay. All right, so 8 divided by, would you hit, let me do this on camera so you guys can see. So 8 divided by 2 square root, and then enter.
Yep.
All right, so let's round that to 2 decimal places. All right, so what would that be rounded to 2 decimal places?
66.
Yeah, but you're rounding the 100.
Right? So each of these sides is 5.66 centimeters. So how can we find the area of the square?
Too high. Pull down.
Oh. How do I find the area of the square?
Base times height.
Which is? Use the information given.
5.66.
Good.
Right, which is 5.66 squared. So 5.66 squared.
32.04.
Right, so we'll do 32.04. All right, so that's the area of the square. So what else did we say we needed to find to figure out the shaded region?
The area of the circle.
The area of the circle. All right, so what do you need to know to find the area of a circle?
Isn't it higher than the radius?
You need the radius, right? What's the formula? Because it's not given to you, you got to know it.
Thank you.
Pi r squared. Remember, if you need to find area, you better square area. I'm here all week, people. Thank God it's Friday. All right, so what is the radius here?
4.
The radius is 4.
This is true.
You should have told us that before.
All right. Now, to avoid rounding again, I'm just going to leave this as 4 pi. All right, can you guys see that? Like really bright. Can you turn off a light? Hit a switch, somebody. All right, so
How about the third one? The wrong third one.
I made a mistake. Did you guys catch it? You're just going to go right along with me off the bridge. Thank you. Thank you. Don't do that. I make mistakes on purpose just to see if you're paying attention. All right, so what, looking at the picture, all right, which area should we be subtracting? Like, in what order should we be subtracting them?
We're almost done, guys. We've just got to subtract the two areas, but you got to know which one to subtract.
Should.
You would subtract the square from the circle.
Okay. All right. So if we approximate 16 pi here,
2.27.
oh, these calculators are different. Okay. So you have to have 16 times pi. Sorry. So that's 50.27, we'll say. So if you subtract these two, I'm going to do this down here. 50.27 minus 32.04, excuse me. So you guys plug that into your calculators and tell me what you get.
I told you where you could go to college.
18.23.
Now remember, we rounded a couple times.
We rounded way too early.
Yeah, we rounded way too early. All right. But can you figure out which one has to be the right answer? It would have to be D. Right? So again, this is, I'm trying to think of, I mean, I guess they could ask all that on one question, do you think?
They use shaded area. Find the area shaded.
No, I know that they could have one that's shaded area like this, but given all the information that we had to find, we had to use a special right triangle, which is your trig. The area of a square and area of a circle are very basic. Subtracting them is pretty basic. So the hardest part there, I think, is the triangle portion. But, I mean, they could ask you a question like that, definitely. Ready to go into the next one?
Yes.
If the measure of angle P equals 120 degrees, what is the sum of the measures of the remaining interior angles? Now, they don't tell us that this is regular, so that means that they don't have to be congruent, correct? All right. So this is sum of interior angles formula?
Yep.
And you guys did that in here?
N minus 2 times 180.
Okay. N minus 2 times 180?
N minus 2 in parentheses.
Yeah.
What's the name of that shape?
A hexagon. Hexagon.
N stands for
Number.
of.
Sides.
Mm-hmm. How many sides do we have here?
So it'd be 6 minus 2 times 180.
Caleb, you go out there and do that all you want.
All right, so what does 4 times 180 give us?
720.
Now look what they did. They gave you 720 as an answer choice,
Oh, that's not it.
so you'd get really, really excited and think that you were done. But what is the question asking you?
The sum of the measures of the remaining.
Yeah. So they give you 120 degrees, and they want to know how many more degrees are left over. So what do you have to do from there?
Subtract 120.
Yes.
So you get 600.
This problem is cake, guys.
That was just looks intimidating. That's a very
Yeah. Are we ready for number 4?
So interior. So did
Don't do that, Mr. Gomez. Mr. He's like a destructive student.
All right. Number 4. A right triangle is shown below. What is the approximate value of x?
Oh, wait.
All right, what do we know about this triangle?
Right triangle.
Guys, there are way too many side conversations going on. If you don't want to pay attention and talk, then sit in the back, please.
I don't know. I'll double look.
All right, we know it's a right triangle. We know, oh, okay. They give us two sides and we're missing an angle.
So what are you using?
Yeah, what do we got to use?
What? If you have the sides, you're missing the angle, you're trying to find the angle, what do you use?
The inverse.
Inverse. Trig inverse.
Yes. So in order to find, you have one angle because we know this is a 90-degree angle. However, they only give you the two sides. So we have to find the angle using inverse trig. So let's label our sides here. All right. What side is this directly across from the right angle? That's the hypotenuse. Slap yourself if you said opposite. All right. What angle are we looking for? Woo! We're looking for x. Don't throw out opposite and adjacent yet. So we need to know the opposite and adjacent side with respect to that angle, right? So what is the opposite side of the angle we're looking for? 8. All right, so this is the opposite. And then process of elimination tells us this is adjacent, okay? So what trig function relates an angle to its opposite and adjacent side? Or, excuse me, we're not given opposite and adjacent. That relates the angle to the opposite side and the hypotenuse.
Sine.
That would be sine. All right, so we're going to do inverse sine. So this is the way I do it. Sine of x is going to be opposite over hypotenuse. What would that be?
8 over 30.
8 over 30. So we want to take the inverse sine of this. So we want the inverse sine of 8 over 30, and that's going to give us our angle. So you guys just, at this point, it's really just, do you know how to plug that into the calculator? And we're going to approximate it. Yes?
So, because it's inverse because the measurements are on the outside on the side.
Say that again?
The measure, it's inverse because the measurements are on
So
the
if you're looking for the length of a side, you're taking the sine. If you're looking for an angle measure, then it's going to be inverse. Okay. Yeah.
See how you maybe try to find which one.
Yeah, if you're looking for one of the angles, you got to take the inverse of the side. Of the right ratio. All right, so we need to do sine inverse. So this one, on these calculators, you have to plug in the fraction first. Is that correct?
Yes.
Right? You guys probably know better than I do because you've been practicing all year. So 8 divided by 3. Oh, I'm sorry. Thank you. Remember what I said about making mistakes? I have 30 written right there. You're not paying attention. 8 divided by 30. And then what do I press?
Then you do second and then press sine.
And I have to hit enter again, I believe.
No.
No? That's it? Okay.
For the inverse, that's it.
For the inverse, that's it. Okay. So what is our angle?
B 15.5.
That's an easy problem, guys.
Right. Yeah.
But you have to know your trig ratios,
And
and you have to remember to take the inverse if you're looking for an angle. Apple pie is cut into 6 equal slices as shown below. The diameter of the pie is 10 inches. What is the approximate arc length of one slice of pie? All right. So if we're looking for arc length, do we want the pie filling or do we want the crust of the pie? We want the crust, okay? And they want to know one slice of pie, all right? So we're looking for a fraction of the crust right here, which means there's probably going to have to be a fraction in the formula, right? So if I wanted to know how much crust this entire pie has, what formula comes to mind for all of the crust? Circumference, which is There's a pi, there's an r, there's a 2, but where does it go? Remember, if you're looking for area, you're going to square area. We're not looking for area here, so we shouldn't be squaring anything. Ah, it works. Whoop, boom, she said it. Right? But we want a fraction. We want a fraction of this, so we're looking for the length of the arc length. So that's where we have the fraction. You guys have seen this? Oh, yeah. It's just a formula. All right, it's just a formula. So the question is, what do we need? We need the angle, which is theta, and we need the radius. We need r. What's a pirate's favorite variable? R. No, 'tis the sea, matey, 'tis the sea. All right, so they tell us that the diameter is 10 inches. So if we know that the diameter is 10, what is the radius?
5.
How did you get that? You're a genius. He has a brain. Beautiful answer. That's true. You all have brains. Just some of you choose to use them more often than others. But what did you get? What did you do to get from 10 to 5? This is important. The people need to know. You divide by 2. You cut it. You cut it in half. All right. How do we figure out what angle goes on our formula? That's the only part we're missing. They told us that the apple pie is cut into 6 equal slices. Okay. But if they were serious about this, it would have been a pumpkin pie because pumpkin is better than apple. True. All right. It's true. Pumpkin is better than it as well. So. Okay. You want to come at me? I'll give you the hands. All right. We have 6 equal slices. So how do you figure out the angle of each slice? Divide what by 6?
You divide 360 by 6, right?
What's 360 divided by 6? All right, now Mr. Como's going to smack you for using a calculator on Math That Easy, but I appreciate your participation. All right, so now it's just a matter of plugging into the calculator. I always choose to reduce here, right? This is a 1/6 of the pi, guys. And look, this is something very simple. For those of you who are afraid of fractions, all right, they tell us that it was cut into 6 equal slices, so automatically I should know this has to reduce to 1/6 because it's a 1/6 of the pi. And 60 over 360 does reduce to 1/6. So we've got 1/6 times 10 pi, right? And we're going to approximate it. We're going to approximate it here. So I need to type in 10 times pi, and then I'm going to divide that by 6. So 5.24 if I'm rounding. Do I see that up there? C as in yes or C as in C? Either way, we got it. Now you can't say this problem is cake, can you?
Not really.
You can't.
You have to find it.
Because it's a pie.
It's as easy as pie.
All right, number 6. Oh, look, a problem about a circular garden. Somebody thinks that circular gardens don't exist, and yet here they are.
Nobody has a circular garden.
Look at that.
Stupid.
Raise your hand if you've seen a circular garden before. Exactly.
That's stupid.
Exactly.
That's stupid.
All right. All right. All right, now guys, look, they tell us that this is circular. They tell us that it is in fact square. All right?
circular means it's a circle, square means it's a square. I know that's shocking stuff. So they have told us that this is definitely a circle and this is definitely a square, which they need to do because there are no markings on that. All right? If the circumference of the circular garden is about 48 feet, which of the following is the approximate length of the fencing needed? Ooh.
Okay. So we know that this equals 48 feet, right? Sorry, I pushed it down too far. And we need to know the approximate length of the fencing needed. Well, all they give us is the circumference. So we know that 2 pi r, right, is equal to 48. That's all they've given us. So from that we can find the radius of the circle, but is that going to help us solve the problem?
No.
That's the only thing I can figure. Are you texting while I'm teaching? If I know the radius, of this. Oh, wait a second. Huh? They told us this was a circle inside of a square, right?
Yeah.
So if we can figure out the diameter, right, what is that going to be equal to?
The radius.
No, the side of the square.
The side of the square.
Right.
Right? Welcome to geometry. Welcome to geometry. All right. So the diameter is in here. So looking at the relationship, looking at the equation we just set up, because that's what's given. So we must be able to use it. How can I figure out the diameter if I know 2 pi r equals 48? I'm not going to multiply. Everything is being multiplied. I want to get rid of the pi. All right? So if we divide both sides by pi, we know that 2r, which is our diameter, by the way, equals 48 divided by pi, which, let's do that and approximate it, I guess. Because they tell us approximately 48. I'm way too close, sorry. How many times have I moved this camera? 48 divided by pi. All right, I'm going to say round that to do decimal places. What are we going to work with?
15.28.
Okay. Oh. Okay. All right, so we know the diameter. What do you mean all that? I did one thing. I divided by pi. All that. All right. So 2r is the diameter. We agree? All right? Yes. 2 times radius equals the diameter.
Yes.
So we divided both sides by pi. I shouldn't have slashed that out. I don't know why I did that. And we got approximately 15.28 as the side of the square. Now, ladies and gentlemen, this is the $1 million question. If we know one side of the square, how can we figure out how much fence we need?
You add them all together. Add them all together. 15.28.
Now, wait a second. I've heard two things. It sounds like somebody wants to add 15.28 4 times, right? Or multiply it by 4. Which one is correct? So it would be wrong if I added up 15.28 4 times. Can't get anything past you. All right, very good. They're the same thing. All right, so you're looking for the perimeter. So it's just all 4 sides, okay? So we've got 4 times 15.28. And they said to approximate. So 15.28 times 4.
61.12.
So if we want to, which one of those is closest? Sorry, 61. All right. I had to think about that for a second.
Now, this one, they gave you information, but it's almost like it was hidden because they told you, you have to pull out from here that this is in fact a circle and that this is a square. All they tell you is that the circumference is 48. You've got to know that that means that 2 pi r equals 48. This is the only way that you can find out anything specific about one of the shapes, which in this case is a circle. So they give you information, they give you the diameter there, but you've got to find it. All right, it's kind of hidden in there. So other than that, it's a pretty easy problem.
All right, but getting there is not easy. Any questions on number 6? I like that question a lot.
But who has a circular garden? That's the real question.
And you guys, when you're driving through your neighborhood, and you see someone whose garden looks like this, you know what that means? They're bad at math. They're bad at math. That's what that means. All right. You can't always fake it till you make it. All right. Oh, I see a triangle inside of a circle. Do you guys remember? When you took a test on Unit 5 and then that was like the end of triangles, but then quadrilaterals, triangles came again, and then circles, triangles came up again? Those darn triangles don't go away. Never. Right? I have to ask you guys, how many sides does a triangle have? 3. 3. Now how many sides does a circle have?
None.
Oh, sure?
Oh, no, it's an infinite amount.
Huh?
What?
Or no?
Nice. Now the joke for those of you who were here before, the joke is it has 2 sides, the inside and the outside. But that is true. The circle has an infinite number of sides. Very nice. Who's this kid? I've never seen this kid before.
He's a sleeper cell.
Oh, okay. Okay. All right.
He slept all year, but
But he's still gonna get a 5? Yeah.
unlike other people, he slept.
Yeah. All right. If Jim, you want to be Jim? If Jim threw a marble inside the circle, what is the probability that it would land inside the circle? This is another geometric probability one. You want to do this one?
Yeah.
I mean, I can do it.
Stop throwing marbles. We can die.
We could actually do a.
Can you tell me?
Well, Mr.
We could do an experiment. We could do an experiment with this and have them throw marbles in an area.
She has good ideas.
That'd be so cool. We could actually do trials.
I'm down. We can throw marbles on the
Forget marbles, we need something
Lawn darts.
bigger that you
Lawn
can
darts.
throw off the second floor.
Hand it back, please. Thank you.
All right. Geometric probability, you're trying to find a probability that you are inside the triangle or no? Would. It would land inside the triangle. So your total area is a circle. It's definitely going to land somewhere inside the circle, so you have to find the area of the circle, which is pi r squared. Your radius is 5. 5 squared pi, which is 25 pi, is the area of the circle. That's your total area. It can land anywhere inside the circle, but you want to know what's the probability of it landing inside the triangle. So you got to find the area of a triangle, which is base times perpendicular height divided by 2. This triangle didn't give you the perpendicular height, but if I draw a line from here to the center, that is perpendicular. That is also the radius of the circle, which is also 5.
Can I say something?
Go ahead.
This is a 3, 4, 5 triangle.
No. This is an isosceles triangle.
That's
Oh, that is 90.
That's a 6 and an 8 circle.
I got you. So yes, this is a right triangle.
Which means that the perpendicular, so you can use 8, right?
No. Yes. 6 times 8 divided by 2. Or, I saw it differently. Mine should work the same way, right? It should. Let's see. I mean, you're right. But,
To use halfway, you have to remember that, and this was a proof, it was a proof that was on your unit test. that a triangle created by the diameter of a circle is always a 90-degree triangle. If you don't remember that, then you can't use her way.
Didn't we just review that on the other one?
Did we?
On the one with the business logo, you were outside on the phone. So the business logo.
We did that on.
So this is your inscribed angle, right? So this is the diameter, which means the measure is half. So this is a 90-degree. Now these two, the sides were equal, so it's 45, 45, 90. The angles are nice, but the sides are messy, right? Because we have the radical.
Right.
Go back to that problem with a 3, 4, 5 triangle. The sides are nice and the angles might be messy. So this is 6, 8, and then 10. You know this is a 90-degree angle, right? Because it's half the measure of the measure is equal to half of the arc, which is 180, so that has to be 90. So if you rotated it and drew your right angle, you could just use, whoa. There you go, now rotate it so it looks nicer, right? So if you do this, see? So now this is 6, this is 8, and this is 10. And if you want to find the area of the triangle, it's just half of 6 times the perpendicular height, which is 8. And then you could go from there. Now you can't rotate your computer screens, unfortunately.
But you can sketch pictures and then rotate that.
Sketch it and then rotate it, yes.
Alright, so here's the area of the triangle. This is the area of the circle. You want to know what is the probability that you're going to land inside the triangle, so it's going to be triangle in the numerator, which is not 12. Triangle in the numerator, circle in the denominator, and then type that in the calculator. 24 divided by
What was the 20? Okay, 25 times.
25.
Now, are you sure that's going to do that in the right order?
No, it did not.
It's not going to do it.
You're going to have to estimate it.
Yeah, so you're going to have to do 25 pi first. And guys, you got to be really careful with that. Hand me a marker, please. Thank you. All right, this calculator, your calculator always defaults to order of operations. So if you hit 24 divided by 25 times pi, all right, this is what you're plugging in your calculator. You want the calculator to do this, right? But if you type this in, your calculator is doing this. Right? And this is not the same thing, okay? We need to divide both by 25 and pi. So the only way to do this correctly is to multiply 25 by pi first.
They have parentheses.
You have parentheses?
I don't like how they work because as soon as, here's how the parentheses work. 24 divided by, I need to use the parentheses, so as soon as I do it, everything goes to 0. So it's going to be 25 times pi, close parentheses, then hit equals.
Okay, well, either way, if you do 25 pi first and round it to decimal places, then you can divide 24 by that number.
You get the same answer.
You're going to get the same answer either way, but you got to be really, really careful.
So this means you have a 31% chance of getting inside the triangle. No, that's 31.
At 31%. The probability is 0.31.
Oh, right.
But if the percentage chance is a 31% chance.
Shh.
We start off with probability and statistics and algebra 2. And your names.
But do you do geometric probability?
I'd have to look at the standards. We didn't do it last year, but I think it might be in the standards. I think you're supposed to do it in here. Because this is a class called geometry.
Right, but it's not in the standards.
It's not?
Sure isn't. We covered geometric probability when we did probability and statistics at the end of the year to get them ready for Algebra 2. But it's not in our standards.
Yeah, but you can still do it because it's good.
It's all it is finding the area of both shapes, dividing them, there you go.
Which is good, yeah. I like that.
Alright. What is the approximate area of the shaded region?
Oh, this.
This is an awesome 30, 60, 90 triangle. The radius is 4, which means the hypotenuse is what? Or the diameter is what? 8. Your 30, 60, 90 is x, x root 3, and 2x. So 8 is, yes. I just drew the special right triangle. Your hypotenuse is, do I need to? I do need this. Dang it.
Hold on. This is the hypotenuse is 8, right?
Yeah.
And I think your 30 degree is in the wrong spot. Well, no, it's not.
Where
Well,
they
if
put
you
it.
want it to be the same orientation as this, it should be up there, but it doesn't matter.
So this is 8,
Yeah.
which means x is
4.
4. So this side, across from the 30, is going to be 4. Across from the 60 is 4 root 3. So that's my base and my perpendicular height of my right triangle. I'm erasing all this. We already got it. To find the area of the triangle, it is 4 times 4 root 3 divided by 2. So 4 times 3 radical divided by 2 is 13.86
Yeah.
approximately.
Yeah.
That's just 8 root 3, right?
This is?
The whole thing is the same thing.
Right. The area of the circle. See you later, Matt.
I see how it is, man.
Pi r squared, well, your radius is 4, so it's 4 squared times pi, which is just 16 pi.
So you would have to, first of all, if you simplify it a little bit more, right? This is 4 times 4, which is 16 over 2 would be 8 root 3. That's what I would do, but you can still plug this in here, right? So you just do all the multiplication first. You just do 4 times 4 times 3 root, right? And then divide that by 2, divided by 2, 13.86. Or if you simplify it a little bit more, you just do whether or not you want more steps in the calculator. I prefer to make what I type to the calculator easy, but if it doesn't simplify, then
To find the area of the shaded region, we just have to subtract the area of the circle, 16 pi minus 8 root 3. So in your calculator, 16 times pi minus parentheses 8 times 3 radical. There you go. In your calculator, I'm doing this. The area of the circle minus the area of the triangle. Oh, you know what?
I wish you had told me about the parentheses before. I would have been using that.
I just figured that out like literally when I told it to you.
Okay.
I don't use parentheses. This isn't the whole circle. This is half the circle. So the area of my circle is wrong. I need the area of the hemisphere, not the whole circle. So you have to take the area of the circle and divide it by 2. Am I looking at that right?
Mm-hmm.
So the area of the circle is not 16 pi, it's half of that,
Which is
8 pi. The shaded region is only up here, which is half the circle, not the whole thing. So when you find the area of the circle, you have to divide it by 2 to get half of it. Now you're going to subtract the area of the triangle from that. So the area of the circle is 8 times pi. Hit equals. To type in minus this mess, you have to minus and then parentheses. 8 times 3 radical, close parentheses, Hit equals
11.28.
What was it? 8 root 3?
Did I do it wrong?
No. I don't think you have to use a parentheses because it defaults to order of operations, multiplication comes first fraction. I just want to see if that's true. 8 pi. You have to hit 8 times pi, right?
Mm-hmm.
8 times pi minus 8 times 3 square root. Yeah, you don't have to do it. But it's never, you can never have too many parentheses.
Oh, you can. Then you get an error.
No, you can't. No, that's too few or too, well. That's why I like Excel. They highlight it when you hit the parentheses to know you have the right number.
That's that, right? Where'd all my stuff go?